All right, unit A lesson 1 probability. We're going to talk about and, or, and not statements. To get started, we're going to make a sample space for spinning a spinner and rolling a 5-sided dice. So, you guys have done this already. How many outcomes are there for rolling the dice? 5. Good. How many outcomes for spinning the spinner? 4. So, how many total outcomes are there? 20. How do we get 20? 5 times 4. Does that make sense? Okay. Now, when I make this sample space, it's just like when we did 2 6-sided dice. We number the top.
A, B, C, D.
Okay, we can do A, B, C, D across the top. I can do it down the side, but that's okay. So, if we do A, B, C, D down the side, what goes across the top? Now, if you did, oops, that'll work. If you did 1, 2, 3, 4, 5 down the side and A, B, C, D across the top, that's okay. Right? Now, in each of these boxes, what do I write? What goes here?
1. A1.
Okay, A1 or 1A, either way. And 1B. 2A, 2B, 2C, 2D, 3A, 3B, 3C, 3D, 4A, 4B, 4C. D, Michael, stop that. Okay. Hopefully your sample spaces look like that one does. Okay? So those are all of our outcomes for rolling the dice and spinning the spinner. Does that make sense? Yeah? Now, what's the probability of rolling a 3 and spinning a B?
1 out of 20.
1 out of 20, right? Because 3B happens once, and there's 20 total. Right? So the probability of rolling a 3 and spinning a B is 1 out of 20. Does that make sense? Kind of a recap of last time? All right. Now, second question down there, I don't know if anybody else got to it, but what do you think independent events are? Okay. Independent events. What do you guys think what 2 independent events are?
Events that happen by themselves.
What is it?
Events that happen by themselves.
Events that happen by themselves, okay. Anyone else have an idea what independent events are? They don't relate to each other? Okay. Anyone else? Okay. All right, can't use the same word that I find it, right? All right, Travis and Chance, you guys are on the right track. Independent events are 2 events that have no effect on each other. Okay? So the independent events are 2 events. What? I didn't major in physics.
What do you major?
Physics? Okay, Chance, I'll change it for you. 2 events that have no measurable effect on one another. Okay? Or how about measurable by standard means? Because it does have a measurable effect if we're talking about butterfly effect, right? Okay. The flapping of butterflies' wings causes a tsunami in there, so it's kind of like a big chain reaction of things. Yeah. All right. So 2 events that have no effect on one another. That's what independent events are. Now, if I spin the spinner, will that affect what number I roll on the dice?
No.
No. If I roll the dice first and then spin the spinner, will there be an effect there? If I roll 5, does it mean I'm going to spin an A? No. So, are rolling the dice and spinning a spinner, are they independent or dependent events?
Independent.
They're independent, right? Because what I do with one won't change what happens with the other one. Okay, they will not affect each other. Okay, so a good example of this would be rolling a 5 and spinning a B. Okay. Rolling a 5 and spinning a B. Those would be good examples of independent events. If I roll a 5, is it going to change the probability of spinning a B?
No.
No. If I spin a C, will it change the probability of rolling a 2?
No.
No. So they don't affect each other. Okay. Another way of thinking about independent events is knowing one event occurs does not change the probability of the other. Okay, so if I know one event occurs, Marcel, if that doesn't change the probability of the other, then the two events are independent. Okay, just to make sure you're paying attention. Okay, a good example of this. Okay, here I have a standard deck of cards with two jokers. Okay, no, I'm not going to show a magic trick. This is a probability trick. Okay, now there's two jokers in here. All right, you guys see the two jokers? Everybody see the two jokers? Okay, I'm going to shuffle the two jokers in here. I'm going to random. I'm going to show you where I can find them. I'm show it. All right. Now, how many cards are in here? Usually there's 52, and I have two jokers. So how many cards total? 54, right? 2 cards, 52 cards, and 2 jokers. So 54. Now, Lynn, I want you to draw one of the jokers. What's the probability that Lynn's going to draw a joker?
4.
Okay, 2 out of 54, or 1 out of 27, right? Okay, so draw one. Oh, is it a joker? No, she got a jack of clubs. Okay, now how many cards are left in here? 53. So if we leave that card out, there's 53, right? Okay, so Lynn, try to draw a joker again. Wait, hold a second. What's her probability of drawing a joker now?
2 out of 53.
2 out of 53. So the fact that she drew this changes the probability in our second draw, doesn't it? Right? Okay, so make your second draw. Did you get it? No, 7 of hearts. Okay, so the fact when she drew this one and she left it out, it changed the probability for our second draw, right? So are those events independent or dependent? They're dependent, right? Because when she pulled out the jack of clubs, we now know that there's one less card, right? It changed our probability for the second draw, making the events dependent. Okay? Now, had we done it this way, draw a card. Okay. Probability is 2 out of 52, right? Right?
Yeah.
Now, if I want to make her next draw independent, what should she do with that card? Put that card back. Okay. Ready? Now draw again. Probability is 2 out of 54 still, right? Did you get it?
Yeah.
You got the same card. Wow, it's crazy. All right. So when she put the card back, that kept the probability the same, didn't it? She had 2 out of 54 both times. Does that make sense? Okay. Do you guys understand the difference between dependent and independent events? Yeah? Okay. Are there any questions? Actually, I need that. Okay. Now, and, or, and not. So you're probably thinking, that doesn't make sense. And, or, not. That's not a very good title. And gets kind of redundant, right, Travis?
Yep.
Where's your notes, bud? Yeah, that stuff's not written down. Okay. Can tell. All right. And, or, not. Now, with and, or, not, guys, we're thinking about how does and, or, and not, how do they affect probability? Okay, so we got to think of what an and statement is, what an or statement is, and what a not statement is. Now, for these, I have probability of x and y. Now, you're probably wondering, wait, x and y are at my table. Is anybody thinking that?
Yeah.
Where do you get the x and y from?
Up and down, sideways.
Nope. X and y are just 2 independent events.
Oh yeah.
Okay? So x and y are just 2 independent events. All right? Any 2. So we're just using them as just kind of like a placeholder for any independent event. So x and y are 2 independent events. Okay. Now, P of x, or probability of x and y. Before we get into the probability here, let's figure out what this means. Okay, if I'm asking for the probability of x and y, what am I asking for? Think of it this way. If I say, pick up your book and pencil, what do I want you to do?
Pick up your book and pencil.
Okay, do I want you to pick up one? No, I want you to pick up both, right? So if I'm asking for the probability of x and y, I'm asking for the probability that x happens and y happens, right? I'm asking for the probability that both events x and y will happen, okay? So probability of x and y is the probability both events occur. Probability of x and y is the probability that both events The probability of X and Y is the probability both events occur. What does or mean then?
One or the other?
One or the other, right? So if I say pick up your book or pencil, right? You could pick up your pencil and you'd still be following directions, right? You could pick up your book and you'd be following directions, right? If you picked up both, would that count?
Yes.
No.
Yeah.
Depends, okay? In English, there's two types of ors. There's an inclusive or and an exclusive or, okay? Usually when teachers say you can do one or the other, they really want you to do both, right? So that'd be an inclusive or. Now, when you're babysitting like a 4-year-old and you say you can have ice cream or cake, right? Okay? You're telling them you can have one or the other, right? Right? That'd be an example of exclusive or. That's where English gets a little tricky. In this case, we're talking about an inclusive or. Inclusive means both counts. Okay? So, if we're doing the probability of X or Y, Greg, that means we're looking at the probability X occurs, Y occurs, or both. Okay? So look at the probability X occurs, Y occurs, or both. That noise is awesome. Now, not. What does not mean?
No.
Not that one, right? If I say do not pick up your pencil, right? That means you can pick up anything you want, but not your pencil, right? Right? You probably will because you're defiant. I don't understand that. Okay. Now, if I do the probability of not X, that means that the probability of what happens?
Nothing.
Nope, not nothing. That means the probability of everything except for what? X. So probability of not X is the probability anything happens except X. So it's the probability anything happens except X. Does that make sense?
Yes.
Yeah. So we understand and, or, and not? Yeah? Okay. I have some examples over here that I'd like you to try. Why are you not going to wear my speaker? I'm just joking. Okay. So, 3 examples get started, and we're going to try these ones on our own. The probability of rolling a 3 and spinning a B. We're going to use our sample space from the spinner and the 5-sided die. Probability of rolling a 3 and a B. That means I'm looking for what? Which box am I looking for?
3B.
Okay, the box with the 3 and with the B, right?
Yes, sir.
So the box that has 3B is the only one that satisfies this condition, right?
Yeah.
So it's 1 out of 20. Because there's 20 total outcomes. Does that make sense? Yeah. Okay, what about the probability of rolling a 3 or spinning a B? What does or mean? What is it, Lynn? Either one, right? So I'm looking for all the boxes that have a 3, right? I'm going to count all the boxes with 3, and then I'm going to count all the boxes with the B. So when I go to count them, right, there's 1, 2, 3, 4 boxes with a 3, right? And there's 1, 2, 3, 4, 5 boxes with the B. So do I just do 4 plus 5?
No.
Why not? Okay. If you pay attention when you're counting, 3B is in the 3 column and the B row, right? So I got to make sure I don't count 3B twice. All right, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So rolling a 3 or spinning a B, it's going to be 8 out of 20. I almost wrote 7 out of 20. All right, it's going to be 8 out of 20. Does that reduce? Yes. What does it reduce to?
That was 9.
2/5. Okay. That reduces to 2/5. Does that make sense? Okay, last one, probability of not rolling a 3. That means I'm looking at everything except for the boxes with what? 3. So we're going to count all of our boxes over there except for the ones with 3, right? So there's these boxes that all have 3s, so I'm not counting those, right? So I'm going to count everything that doesn't have a 3. So 1A, 1B, 1C, 1D, 2A, B, C, and D, 4, and 5, those all work, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the probability is?
4/5.
Oh, 4/5. Nice reduce right there. 16 out of 20, which reduces to what, Michael? 4/5, or 80%.
Listen to chance.
Do those make sense? Guys, do those make sense?
Yep.
Okay. I'd like you to try these 10 on your own. Okay? Try those 10 on your own. Yep.